right, the last section that we worked on was multiplication properties of exponents. In this section, we are going to look at division properties of exponents. So let's look at this first problem that we have. We have 3 to the 5th divided by 3 squared. Now, if I write this in expanded form, this is one way that we can write it without exponents. If I write it in expanded form, we'll have 3 times 3 times 3 times 3 times 3 divided by 3 times 3. And notice that these cancel and these cancel, and I'm left with 3 times 3 times 3, or 3 squared, or 3 cubed, I'm sorry, 3 cubed, which is 27. Now notice we got 3 cubed as our answer before I wrote out the actual answer. What happens if we take 3 to the 5 minus 2? What do we get? We get 3 cubed. Let's see if that same thing works in this problem. Let me make this just a little bit bigger here. If I have x to the 10th, it's going to take a while, but x times x times x times x times x. I think that's 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I divide that by x to the 5th. 1, 2, 3, 4, 5. Notice that these cancel, these, and these. And I am left with x to the 1, 2, 3, 4, 5, x to the 5th power. What happens if I come back over here and say x to the 10 minus 5? We still get x to the 5th power. So we can see examples here of how to use the quotient power rule. If we divide powers with the same base, let me make this a little smaller there. If the bases are the same and you are dividing, then we subtract the exponents. So let's look at a couple of problems here. We want to work some of these. Now I'm going to separate these out a little bit. You don't have to do it exactly like this every time, but you may want to the first time or two. If I look at x cubed y to the 4th divided by x squared y, remember, if the bases are the same, we subtract exponents. So I'm going to separate this into a multiplication problem. And we have x cubed over x squared and y to the 4th over y. So if we have x cubed over x squared, that's the same as saying x to the 3 minus 2, which is, let me go ahead the first time and write this out, x to the 3 minus 2 times y to the 4 minus 1. Remember, anytime there is not an exponent, a 1 is understood. So we will end up with xy cubed. Subtract the exponents here and subtract the exponents here. Let's look at this next one, k to the 7th, m to the 10th, p, over k to the 5th, m cubed p. Now right off the bat, we can see that p over p, these cancel. So that's taken care of. Let me change this back to blue. And we're going to have k to the 7th over k to the 5th, and that is a k, not an 11, times m to the 10th over m to the third. So for k, we have 7 minus 5, which is 2. And for the base of m, we have 10 minus 3, which is 7. So this is k squared m to the 7th. Okay, I'm going to give you about 15 or 20 seconds to do the last one. I want you to go ahead and do that one and see what you come up with, and then we will check it. Okay, if we have our x's grouped and our y's grouped, we were going to have x to the 7 minus 6, which is x to the first power. You can put the 1, but it is certainly not necessary. And then we will have y to the 12 minus 3, and 12 minus 3 is 9. X, y to the 9th. Now let's look here. This is a little bit different, not a whole lot, but a little bit different. Let's look and see what happens if we have the power of a quotient. In other words, I have 2/3 squared. We've worked some of these before, I think, but that's basically saying we've got 2/3 times 2/3, which is, sorry about that, 2/3 on the bottom, 2 squared over 3 squared. In this case, we can easily figure out what that is. That is 4/9. Right, if we look at the next one, same kind of idea. We'll have a over b times a over b times a over b, and that's a cubed over b cubed. Notice this exponent applies to both the numerator and the denominator. So the rule to find the power of a quotient is that the exponent applies to both the numerator and the denominator. In other words, if I have a over b to the m power, that's a to the m over b to the m. You cannot do just the numerator or just the denominator. So let's look at some of these and work through them. Now it applies to each part of the numerator and to each part of the denominator. In this particular problem, we could think of it as 3x to the 4th cubed over 4 cubed. And you can't forget, you have to cube the 3. So 3 cubed and x to the 4th cubed. Remember, if we are raising, well, we'll just do it this way. I probably should have left myself some more room. Over 4 cubed, and 4 cubed is 64. I'm going to go ahead and say 64. Let me see if I can get myself a little bit more room here. All right, now 3 cubed is 27. X to the 4th cube, remember, if we raise a power to a power, we multiply the exponent over 64. And 27 and 64 have no common factors, so we're done. All right, let's look at this next one. Move things over a bit. Give me some more room to work. Remember, we are going to square the numerator and we're going to square the denominator. So I could rewrite this as 2y squared. That's not always a bad idea because you need to remember that you are also applying the exponent to the constant part of this number. Remember, this is not a monomial because you're dividing by a variable, so it's not a monomial. All right, I'm going to change the color so you can easily see the difference between the problems. Okay, so we're going to have 2 squared times y squared squared. Just writing it out a little bit longer than I normally would so you can see where everything comes from. 3 squared over z cubed squared. And this becomes 4y to the 4th over 9z, multiply the exponents to the 6th. When you raise a power to a power, you multiply the exponents. Okay, I'm going to give you some time to work this last problem. See what you can do with that. If you have to figure out what the constant term is, you may use a calculator, but you really should know what these particular ones are. So go ahead and see what you can do with that third problem. Okay, not going to take quite so many steps as I did on the previous two, but let's see what we can do here. We know we're going to have 4 cubed x to the 9th, 3 times 3 is 9, over 5 cubed y to the 4 times 3 is 12. And this becomes 64 x to the 9th over 125 y to the 12th. Now, I don't think it's unreasonable for me to ask you to know what 4 cubed and 5 cubed are. Okay, we want to look at the zero exponent property. And you're probably going to get to where this is one you like the best. When you see something raised to the 0 power, you're going to be very happy. Now let's look at a couple of different ways. Notice I have the same problem twice, and we're going to work it 2 different ways. We're going to do it using the rule that we just talked about, and that's 2 to the 4th over 2 to the 4th is 2 to the 4 minus 4, which equals 2 to the 0. Or we could write it in expanded form, 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2. Well, they all cancel out, and we end up with 1. And from this, we can see that 2 to the 0 is equal to 1. Anytime we have a 0 exponent, the value of that problem is 1 if we have a 0 exponent. Okay, so here we could say that any non-zero number raised to the 0 power always equals 1. So I like this next problem. It looks pretty complicated. 2f to the 4th, g to the 7th, h to the 3rd over 15, f to the 3rd, 9th, g to the 9th, h to the 6th. But notice it's raised to the 0 power, so this whole thing is simply equal to 1. If we look at this problem, well, we have b to the 4th c squared d to the 0 over b squared c. Well, d to the 0 is 1. So we have b to the 4th over b squared, which is b to the 4 minus 2, over c squared over c, times c squared over c, which is c to the 2 minus 1. So that is simply b squared c. Okay, I want you to do the next one. M to the 0 n cubed over n squared. That should not take you very long at all. M to the 0 is 1. So we have n cubed over n squared, which is n to the 3 minus 2, or just n. If you put n to the first power, it's not wrong. It's just not something that we normally do. All right, this problem is a little different in that the higher exponent is in the denominator. So let's use the rule that we just learned, which is subtracting exponents. This would be c to the 2 minus 5, which is equal to c to the negative 3. It's one way we can work that. Or we can go back to the old way of expanding this, c times c over c times c times c times c, and I'll put this one in the front. Now notice that this c cancels and this c cancels, and we are left with 1. This doesn't just go away in the numerator, that's a 1 because they canceled out. There's a 1 over c cubed. So we could say that c to the negative 3 is equal to 1 over c cubed. The negative exponent property tells us that a to the negative n is the reciprocal of a to the n. Now when I say reciprocal, let me just move this kind of out of the way. We'll come back to it. If I have 2, the reciprocal is 1/2. If you multiply those two together, you get 1. If I have 3/4, the reciprocal is 4/3. So if we have a to the n, it's the a to the negative n is the reciprocal of a to the n. In other words, if I have 2 to the negative 4, I can rewrite that as 1 over 2 to the 4th, which is 1 over 16. If I have 1 over j to the negative 4, that's just going to be equal to j to the 4th. If the negative is in the denominator, it just moves that base and exponent to the numerator. If the negative is in the numerator, it moves that base and exponent to the denominator. Okay, let's look at this problem. I'm going to separate them out again like we did on the other examples. And we are going to have negative 5 over 20. And of course, you're going to want to reduce that. And we will have r to the negative 3 minus 2. We'll have t to the 4 minus 7. And we will have u to the negative 5. So negative 5/20 becomes negative 1/4. R to the negative 5th, t to the negative 3, and u to the negative 5. Now this is not simplified as long as we have negative exponents. So we are going to simplify this, and we're going to have notice all the exponents are negative, so all of those terms are going to move to the denominator. We're going to have a negative 1 on top, 4 r to the 5th, t to the 3rd, and that's a 3, u to the 5th. You know what? I just realized I looked at that wrong. This was, let me erase, and this one I need to erase because that was 1 over u to the negative 5, which means that becomes u to the 5th in the numerator. So we have a negative u to the 5th for r to the 5th t cubed. Excuse me for that. This should have been 1 over u to the negative 5. Right? Let's look at this next one. These take a little bit more thought, but you can easily work these. Now notice I don't have any common bases here. So when I have x to the negative 4, I can just move that down to the bottom. And when I have z to the negative 6 in the denominator, I can move that to the numerator. And y to the 9th stays exactly the way it was. So this becomes z to the 6th, y to the 9th over x to the 4th. Remember, since no common bases, I can just move them up and down based on whether the exponents are negative or are positive. Let's do another one together before I have you do one by yourself. Okay? We can group these if we want to. I'll just go ahead and do it here. And notice this one's going to stay the same. A 1's understood if it's not there. So, 75/15. We know that 15 goes into both of those. 15 goes into 75 5 times. And then we're going to have p to the 3 minus 5. M to the negative 5 minus a negative 4. And 1 over r to the negative 8, we can just write that as r to the 8th. So we have 5 p to the negative 2. M, negative 5 plus 4 is negative 1. R to the 8th. The 5 is going to be in the numerator. R to the 8th is in the numerator. And p squared and m move to the denominator. Okay, I want you to take a few seconds and work through v to the negative 3 wx squared over y w y to the negative 6. Go ahead and work that on your own, and then we'll come back and we will check it. Okay, let's look at this. Anything common? Common bases anywhere? Yes. W and W, they have the same exponent, so they cancel each other out. Notice none of the other bases are common. So, v to the negative 3 can move to the denominator as v cubed. X squared stays in the numerator. And when we look at the denominator, y to the negative 6th can move up to the numerator as y to the 6th, and that problem is finished, and it really was not that bad. One more. This one's looks a little bit more complicated, but it may not be too bad. I would like for you to take about a minute and work through this problem. Go ahead and start, and then we will come back and check it all together. Okay. Maybe one of the easier things for you to do would be to sort of group things. We're going to have this grouped, the A's grouped, the B's, and the C's. So 4 goes into 32 8 times. We're going to have A to the negative 8 minus 3, B to the 3 minus 5, and C to the negative 4 minus a negative 2 becomes plus 2. Don't skip steps. 8, A to the negative 11, B 3 minus 5 is negative 2, and negative 4 plus 2 is negative 2. So the only thing in the numerator is 8. Everything else moves to the denominator, and in the denominator you'll have a to the 11th, b squared, c squared. So while it looked kind of bad, it was not difficult at all. Okay, on Friday you will have a quiz on Alex over section 7.1, multiplication properties of exponents. And your assignment, this is assignment number 2. It's also in the lesson plans on RenWeb. Assignment number 2, due Friday, is page 402. And it's 2 through 32 even. And you may omit number 18. Blessings to all of you.